Okay, so let's look at the first homework problem from chapter 7. And we've got this exponential growth equation right here. Oh, here, let me highlight it. Right there. Uh, so it's going up. It's a growth equation because that base there is 1.024, which is bigger than 1. So it's growing. And the first part says, let's look at what p of 0 is. So p of 0, we know p of t is 5280 times 1.024 to the t. So it's going to be 5280 times 1.024 to the 0. And anything to the 0 is just 1, so this is 5280 times 1, which is 5280. And this is a town's population, so that's going to be people. So what does it mean? Well, it means that when we first started monitoring this town's population, that's times 0, we had 5,280 people. So you can kind of think of times 0 as now. So, or initially, the town has 5,280 people. Whatever time it is when we started keeping track. And if you think about it also, when t is 0, we have 5280. That's actually this spot right here on the graph. So I'll mark that in red. And this location is when t is 0, we get p is 5280. So it's a point on our graph as well. Part B says, use the graph to estimate when p of t is 10,560. So that's when the p-value is just over 10,000, halfway between 10,000 and 11,000, so right about here. So that location right there, if I come down, looks to me like it's right around 30 years. So I would guess that this point is about 30, 10, 560. Right? This is just kind of a guess. So for B, I'm going to say that the solution is about t equals 30 years. Okay, let's do C. So C says actually solve when the population is 10,560. So that means P is going to be 10,560. So the way we solve that is set it equal to our function, right? 5280 times 1.024 to the t. So here's what we're solving right there. So let me divide both sides by 5280. Divide by 5280. Divide by 5280. Those cancel. And so I'm left with, this left side ends up being 2. And then the right side is 1.024 to the t. Okay, now there's a hint here. We're solving for t. And we came across something like this in class where it's in the form b to the c equals a. And you might remember this change formula. So there's something log base b of a equals c means the same thing as b to the c equals a. So if I have something in this form, I can rearrange it so it looks like it's in this form. And really the key here is if I need the c, the exponent, because then I can write it as a logarithm instead. So let me line up what I have here. 1.024 is my b, 1.024. The c is a t, and the a is a 2. And so then when I rearrange this, I'm going to get log base b 1.024. A is 2, and c is my t, which is what we're looking for. So this is what I need to type into my calculator. So let me get the calculator up here. Is this going to turn on, or do I need to restart? There we go. So I'm going to do alpha f2. Whoop, it's got to turn on. Alpha f2. Choose log base, number 5. And then it's 1.024. And I'm taking the log of 2. If I hit enter, t is about 29.23 years. Which is a pretty good, I mean, that 30 that we guessed earlier was a pretty good estimate then. Okay, so that's C. That means that it'll take 29.23 years for the population to reach 10,560. Okay, so that's C. Let's do D. D says calculate P of negative 30. Okay, well, that's going to be what happens when I plug in negative 30 in right there. So that's 5280 times 1.024 to the negative 30th. So if I plug that in, let's do that on the calculator here. So it's 5280 times 1.024 to the negative 30th. And that is 2,592 point, well, since it's people, let's just leave it like that, people. Since P is in terms of people. What does that mean? Well, it means if this pattern existed 30 years ago, then 30 years ago, that's how many people there were. So this is the population 30 years ago, because T is a negative number. Okay, and then it says comment on the graph that's outside the borders of the picture. Well, okay, so over on the right side, this thing's just going to keep going up like that, steeper and steeper and steeper. Over on the left side, this thing's going to get closer and closer and closer to 0 without ever going past it. So out here, we've got an asymptote of y equals 0. And over here, it just keeps going upwards to infinity. And the idea is, well, if I go backwards in time, the population decreases. It gets smaller and smaller and smaller, but you can never have negative people, so you never actually get past 0. Whereas on the right side, well, if I keep just the population growing, it'll just keep going up and up and up. Okay. Hope that helps some. And okay, keep watching the correction videos.